Good afternoon. My name is Richard Chrysler, and I'm going to talk to you about the second experiment in the process control lab cycle, process dynamics. So one thing I want to try to get a little clearer is the difference between the experiment numbers. So for temperature, if you have a temperature control experiment, that would be either 610 or 620, you're going to work with the same apparatus. So it's going to be one of these apparati here, the RT040 from Gunt, and you will work with this experiment for the whole lab period, whether you're doing 620 or 610 over here. It's the exact same apparatus, so you'll work with this one. But in addition, you're also going to work with the second apparatus over here. Now this apparatus I wanted to include for both the 600 series experiments because this is more like a real system. This is what you'll actually be doing when you get a job, is you'll have to specify components, put them together, get a controller, program the controller, and get everything to work. That's what you'll have to do in the real world. These other experiments are really nice. They were made by a team of engineers, and they function very well under the conditions that you're going to operate them in. They have a nice software program already written for it. It saves the data for you and everything, and it's great. But it doesn't have the same learning value, I think, as these kind of homemade experiments, so to speak. So that's why I want you to have exposure to both of them. Plus, we're going to keep expanding our knowledge with writing control configuration files, so you get more used to doing that. So whether you're doing 610 or 620, you'll be working with these apparati, but you'll also work with this unit as well. In the first hour and a half, the team assigned to experiment 610, which is over here, will also have access to this equipment as well. And I'm picking up another computer this afternoon, so we should have a separate computer to be able to write the control file to the computer. And then the second hour and a half, the team that's working on 620 will have access to this apparatus. So first hour and a half, there'll be one student on 610 over here, one student on 610 over here. Then the second hour and a half, one student from 620 will be over here, and then second student will be over here working with this apparatus for the last hour and a half. And so what you're going to do, we'll start with the Gunt unit, for example, is we are going to, when you come in, the system will already be at some steady state. And if you have any questions about the software, if I don't explain everything clearly now, you can just ask either myself or Robert, and we'll explain it to you. But initially, so when you come in, it's going to be at some steady state. And what we're going to do is we're going to cause a disturbance from the steady state and let it reach a new steady state. And then you'll also be changing the proportional. In this one, it's going to be the gain. So you have to keep in mind that there's gains and proportional bands. This one uses a proportional band, and this one uses a gain. So you need to know, keep straight in your head which one you're going to change and in what direction, because it will have the opposite effect depending on which one you're working with. And so we'll keep the derivative times 0 for the whole lab period. And the interval action time, we're going to change that, but we'll change that kind of a little bit later on. Now, when you read the experiment instructions, we're going to give you very specific guidelines on what we want you to change first, second, and third, and what constitutes a complete trial. So when you see the instructions, all of that will be very clear to you. So if I change the gain, and what will happen is that you can see that all I did was I changed the gain, and the system is going to have some response. Depending on how much I change the gain, the system may not respond very much, or it may respond a considerable amount. And so once you make that change, you'll wait for the system to reach a new steady state. And then once it reaches a new steady state, you'll then change another parameter. We'll also be changing the set point value as well at some point. And so you'll change it there. And so in the in the lab instructions, I will give you information about what these W, X, and Y mean, but basically this is your set point here. This is the actual value here, and there's actually 3 X's because there's a metal bar in the middle of this insulation, an aluminum bar, and there's 3 temperature sensors, and the heater is actually down here on this end. So this is the first temperature, X1, that's represented here. Second one here is X2, which is this one in purple, and the third one is X3. And you kind of should already guess that X1 is going to respond much faster since it's closer to the heating element than either X2 or X3. So we're going to focus our primary attention on X1, and so basically when X1 reaches a new steady state, that's when we want you to then introduce the next change and start the next part of the trial. And then eventually what we'll also do is we will change integral settings on here, and you'll see the effects of that. And again, that'll be clear when you look at the experiment instructions. Now with respect to the controller configuration program of the file, again, when you come in, the system will be at some steady state. And for this one, what we have to do is go to the output 1, and here's where your proportional band, then this uses proportional band instead of gain. And then you have reset, and then you have rate. So this rate is the derivative setting, which will keep to 0 the whole time. The reset is the integral setting, which you will change in part of the experiment. And so if we make a change, here, and make a change here. Once we make a change and we want to send that information to the controller, what we have to do is we have to write it to the controller. So we then click the write button, then you want to select the serial port, and so what it's going to do is it's going to pop up a bunch of boxes for you to say, is this okay to make this change? And you just say yes, yes. And I know it may seem a little irritating, but believe me, it's much better than trying to program it from the front panel. And then so what we did was, we made the changes here on the computer, and we then sent that information to the controller, and now the controller is going to respond based on that new information. And that's what we're kind of interested in the response. In addition, we'll also introduce a disturbance variable, which will be the flow rate through the heater. And so that can be stepped up or stepped down. If you step down the flow rate, you want to be careful not to exceed the 60 degrees C temperature safety point. So, which you can step it up and step it down. Again, just be careful. If you start to exceed that 60-degree temperature limit, there's 2 things you can do. You can either increase the flow rate back to some value where you're going to be below that 60 degrees C, or there's some other issue that you can't, for some reason you're having other difficulties. You can always just turn this the switch off. This is what connects the output from this device to the actual heater. And so if you turn that off, basically you've stopped sending output to the heater. So again, just be careful when you make the step changes, not to exceed the 60-degree temperature safety limit on this. So again, I know that's a lot of information in a short period of time. And the changes that you'll make in what order, we're going to give you some information on how to do that and what the order we want you to go in. And then, provided you have enough time, you can explore other settings if you would like. Thank you very much.